Hello folks, welcome to my Tech Hub. In this video we are going to learn about how to implement an OTP verification service. For security reasons, many software applications don't store the raw OTP value. Then the question comes into your mind, how does the OTP verification works without storing the OTP value? Here is the secure solution that is a hashing technique. Instead of storing the plain OTP, the system has to store the hash value which is generated from the OTP. To generate the hash value we can use one-way message digest algorithms. Those are MD5, SHA-256, SHA-512 and few other. These message digest algorithms generate a unique hash value for the given input that will be a hexadecimal format. To generate the same hash value you have to pass the same input. You can use these algorithms at the time of OTP generation, and you can return in the plain OTP to the end user after storing the hash value of the OTP, when you get an active OTP for the verification process. Then you have to generate the hash value for the incoming OTP, and then compare it with the stored hash value. If both the hash values are the same, then you can consider the verification process succeeded. This way even system admins won't even get to know what is the actual OTP. Before jumping into the coding part, please do like the video if you find it useful. Here I'm creating an OTP class with three properties. Those are identifier, expiry date of OTP, and the hash value to hold the encrypted text of a plain OTP. If you notice here, I have not created any property to hold the plain OTP. To store the runtime OTP information, I am creating a concurrent hash map, which is a thread-safe object. This concurrent hash map object we have to use at the time of OTP verification process to get the end user associated OTP object, and in the real-time implementation, we should not refer any in-memory solution to store the OTP related information. We require a private method to generate a 4-digit OTP. Here I'm using a random class to generate the 4-digit OTP. Another critical private method is for generating the hash value for the plain OTP. Here I am creating an instance of SHA-256, which is not a thread-safe object. That's the reason I am creating a new object within the method itself, and the message digest method returns a byte array which we need to convert into hexadecimal format. Now I'm gonna use both the private methods in another private method. This method is responsible for creating the OTP object with expiry date and the hash value of the OTP, and that object we are going to store in the concurrent hash map that we created initially. If you notice, I have given 60 seconds as an OTP expiry time. Now I am going to create a public method that should return a plain OTP to the end user. In real-time implementation here we need to integrate with the message service provider to send a message to end consumer. In the same way, validate OTP method is going to reuse the private methods that we created earlier, but this time we generate a hash value for the incoming OTP. And also we have to verify whether the respective OTP object is expired or not. If it is not expired, then only we have to compare the hash value of incoming OTP with the stored hash value. Finally, we have to create the public method for validating the incoming OTP internally. It's going to reuse the private method that we created above. The actual fun part. Let's test with the positive test case, which is a valid OTP, and then we'll test with the invalid OTP test case, where I'm gonna pass the wrong OTP, and then not found when the system encounters an invalid user identifier.